In this video, we're going to talk about arithmetic sequences. Terms to know. A sequence is an ordered list of numbers separated by commas. A term is a number in a sequence. Subscripts are usually used to identify the position of the term. And those two are just like the recursive sequences that you learned perhaps in a previous video. Now, an arithmetic sequence is a sequence that has the same difference, the common difference, between any pair of consecutive terms. The general term is a formula labeled T subscript n that expresses each term of a sequence as a function of its position. So for example, if the general term is Tn equals 2n, where n is a subscript on T because it's indicating the ordinal position, but the n on the right side of that equation is not a subscript because we're performing an operation on it, then to calculate the 12th term, in other words, to calculate T12, we would substitute in n equals 12. So we'd say T subscript 12 equals 2 times 12, which is 24. Some sequences have a discernible pattern and some do not. The ones that have a discernible pattern are recursive, and a special subset of recursive sequences are arithmetic sequences. Some sequences, for example, the sequence 221, 154, 699, 429, 322, 743, and 832 has no discernible pattern. It's actually license plate numbers that I've had on my cars over the years. There's no pattern there, so it's not possible to know what the next term would be. Other terms have a distinct pattern, and we can use that pattern to help us figure out what the next term would be. And sometimes, as I stated a minute ago, the distinct pattern is that we're adding the same value from each term to the next. When that's the case, we call the value that we're adding from each term to the next the common difference. We label it D. We denote the first term by A, and we state that the general term formula is given by T subscript n equals A plus quantity n minus 1 times D. Now, let's establish that formula. It's actually not too tough to establish. The first term is A, so we can say T subscript 1 equals A. To get to the next term, we add D, so therefore T subscript 2 is A plus D. Then if we add D again, we get the third term, so in other words, T subscript 3 is A plus 2D. Then to get to the next term, we would add D again, so T subscript 4 would be A plus 3D. And as you can see now, from each of those blue equations, we're developing a pattern such that for any positive integer n, T subscript n would be A plus the quantity n minus 1 times D. So let's determine whether the sequence shown is arithmetic. We can see that the second term minus the first term is 14. And we can see that the third term minus the second term is also 14. And we can see that the fourth term minus the third term is also 14. What we've just shown is that to get from negative 20 to negative 6, we add 14. To get from negative 6 to 8, we add 14. And to get from 8 to 22, we add 14. Since there's a common difference, the sequence is arithmetic. Now, using that same sequence, let's determine the 77th term. Well, rather than having to add 14 so many times, let's just say really simply that we have an arithmetic sequence, and we just showed that it was arithmetic. We know the first term is negative 20, so we'll call that A. We, again, just remind ourselves that the common difference is 14. If you ever know that you have a common difference, if you ever know that you have an arithmetic sequence and you want to know what the common difference is, take any term and subtract the prior term, and that'll give it to you. So in this case, 14. So we know that Tn will always equal A plus n minus 1 times D. Subbing in an A value of negative 20 and a D value of 14, we get that Tn equals 14n minus 34. Okay, well, to know the 77th term of the sequence, we're simply just going to let n equal 77. So T77 will be 14 times 77 minus 34, which is 1,044. The 77th term of that sequence is 1,044. Now, what if we're given the arithmetic sequence shown here? Now, since the question tells us that it's an arithmetic sequence, we don't have to show that it's an arithmetic sequence. So we can say right away, well, our first term is 3, so that's A when we're talking about arithmetic sequences. We take any term and subtract the one prior. So -5 minus 3 is -8. So that means we're always adding -8 to get to each subsequent term. So Tn will be A plus n minus 1 times d. So we sub in the value of 3 and the value of -8 where they belong. We distribute the -8 into n minus 1, and we can say that Tn equals -8n plus 11. So the general term of the arithmetic sequence is shown there. And specifically, just to really clarify it, the part that I'm circling, that is the general term. T subscript n equals -8n plus 11. Now, what if we wanted to know the number of terms in the arithmetic sequence shown? Okay, well, what we could do, again, the question tells us it's arithmetic, so we don't have to show that. A is 16, the first term. We can see that we're always adding 7 to get to each subsequent term. So we can develop a formula for the general term, and we can say the general term of this arithmetic sequence will always be T subscript n equals 7n plus 9. Okay? Now that we know that, what we can do is we can say, I'm going to let 1,479 equal Tn. And then I'm going to solve for n. And once I solve for n, that means I know the subscript. So if n ends up equaling a certain value, I'll know that that's exactly how many terms are in the sequence. So I let 1,479 equal Tn, which means 1,479 equals 7n plus 9. Subtracting 9 from both sides and dividing by 7, we get 210. So we have 210 terms in that sequence. So 1,479 is the 210th term of the sequence, so there are 210 terms in the sequence. All right, now let's figure out whether the number 1,818 is in the sequence shown. Well, it tells us it's arithmetic, so we don't have to show that. So A is 203 and D is 13. In other words, we're always adding 13 to get to each next term. Okay, so we can determine, subbing in an A value of 203 and a D value of 13 to the general term formula, we can determine that the general term is 13n plus 190. Now, what we're going to do is we're going to let 1,818 be the general term. And then we're going to solve for n. Remember, n has to be a positive integer because it refers to the ordinal position of the term. Well, if n is a positive integer, then the number 1,818 will be in the sequence. But if it's not a positive integer, then that number won't be in the sequence. So we let 1,818 equal 13n plus 90, do a couple steps of solving, and we get an approximate value of n of 125.23. Well, you can't have a term in the 125.23rd ordinal position. It's impossible. So therefore, that number is not in the arithmetic sequence. Now, what if we're told that the 39th term of an arithmetic sequence is 111, and the 85th term is -73, and we'd like to know the 400th term? Well, what we're going to do, we're going to figure out what A and D equal. We know that Tn equals A plus n minus 1 times D. So if n is 39, then T39 will be A plus 39 minus 1 times D. So in other words, the 39th term is equal to A plus 38D. Since the 39th term is 111, we can say that 111 is equal to A plus 38 times D. Following a very similar process, we know the 85th term will be A plus 85 minus 1 times D, meaning the 85th term is A plus 84D. But we know the 85th term to be negative 73, so negative 73 equals a plus 84d. And rearranging equation 1, what we've got here, if you look at equation 1 and equation 2, is two equations with two unknowns. So we're going to use either the method of substitution or elimination. I'll use the method of substitution. So what we're going to do is we're going to solve for a, rearranging equation 1, which is the one I'm circling here. We see that a is equal to 111 minus 38d, just bringing that 38d over to the other side. And we're going to now take that expression for a and sub it into the second equation. Okay, so subbing that into the second equation, letting a be 111 minus 38d, we get that negative 73 is 111 minus 38d plus 84d. Subtracting 111 from each side and collecting up our like terms, we get that negative 184 equals 46d, meaning d is negative 4. Well, we also know that a is 111 minus 38d, so since d is negative 4, that means a must be 263. What we've done now is we've solved for a and d, and once you know what a and d are, you can basically figure out anything you want about an arithmetic sequence. So we know the values of a and d, we know the formula for the general term of an arithmetic sequence, so we can say T400 will be a, which is 263, plus n minus 1, which is 400 minus 1, times d, which is negative 4, and we simply evaluate. We get negative 1,333. So the 400th term of that sequence will be negative 1,333. Now, what if we're given a sequence that has some fractions? Well, no big deal. We just we're confident enough to deal with that. We want to show that that sequence is arithmetic. We want to state the general term in simplified form, and we want to state the 99th term. Well, to show that it's arithmetic, we need to show that there's a common difference. So we'll show that the difference between the first and second term equals the difference between the second and third term, because that's all we're given. So when we subtract 11 and 5/7 minus 8 and 3/7, we get 23 over 7. So in other words, to get from T1 to T2, we add 23 over 7. Similarly, subtracting T3 minus T2 also gives us 23 over 7. So to get from the second term to the third term, we add 23 over 7. That means there's a common difference between the terms. That means we have an arithmetic sequence, and specifically d is 23 over 7. Well, we know a is 8 and 3/7. It's right there. So we'll put that in in improper fraction form, and we'll call it 59 over 7. It's much easier to do mathematical operations with improper fractions than with mixed numbers. So it's a good idea to convert everything to those improper fractions. Now we simply use our formula, our trusty formula here. Tn is 59 over 7 plus n minus 1 times 23 over 7. Distributing this 23 over 7 in, we get 59 over 7 plus 23 over 7n minus 23 over 7, which ultimately is 23 over 7n plus 36 over 7. That is our general term formula right there. Okay, now that we know that, let's figure out the 99th term. Well, we simply let n be 99 in the subscript on the left, and we let n be 99 in the formula on the right, and we end up with 330 and 3/7. Okay, what we end up first with is 2,313 over 7, but since the question was giving us values in mixed numbers, I just thought I would switch it to that myself when I gave the final answer, even though I was using improper fractions throughout. Now, what if we're given a sequence shown here? This is a little bit different because we have a lot of variables here. We want to show that the sequence is arithmetic, state the general term in simplified form, and state the 99th term. Well, what we need to do is determine that whatever you need to add to get from the first to the second term is the same as what you need to add to get from the second to the third term. So, subtracting backwards T2 minus T1 and distributing our negative signs and collecting like terms, we get that T2 minus T1 is negative 3c plus 2h, And T3 minus T2 is also negative 3C plus 2H. All right, well, so that's interesting. That means in order to get from the first term to the second term, we add negative 3C plus 2H. And in order to get from the second term to the third term, we add negative 3C plus 2H. Now, since the differences between the terms are the same, that means it's arithmetic, and we know the value of D. Now, for the second term, let's get the general term of that sequence. We know A will be 42C minus 12H. It's the first term. So we plug that in for A, and for D, we plug in negative 3C plus 2H. And we're now going to distribute. And when we do that, we end up with 45C minus 14H minus 3CN plus 2HN, and distributing that a little bit and factoring out the n, because we like to have, you might have noticed we like to set it up so that n is a factor of that second term. We can say that 45C minus 14H plus n times negative 3C plus 2H is our general term. Now, to get the 99th term of the sequence, we simply sub 99 in for the subscript n on the left and sub 99 in for n on the right. And we distribute 99, and we get 45C minus 14H minus 297C plus 198H. In other words, negative 252C plus 184H. And there is your 99th term.